Video topic 2, Zirconium by Jaden Stott. What is zirconium? Zirconium is the 40th element on the periodic table, first being identified in 1789. It is a impure metal that is both very hard and brittle. This metal became a significant metal towards the late 1940s in engineering due to its material for nuclear energy because, because of its ability to be highly transparent to neutrons. The most important use for this metal is in cladding fuel rods inside of nuclear reactors. It's a good alloy for uranium in reactor core structures due to its wide variety of properties. On top of that, zirconium is able to withstand elevated temperatures, resist corrosion from rapid coolants, and does not form highly reactive isotopes, and withstands many different mechanical damages. This image on the bottom right shows cladding fuel rods inside of a nuclear reactor. These rods are a critical component to be sure everything runs properly in the reactor, such as containment of radioactive products, structural support, and heat transfer. About 98 to 99% of those rods are made from the metal zirconium. The two methods of refining zirconium. First, zone melting and purification. The first step is to prepare the raw zirconium. This is done by sponge zirconium or zirconium iodide, being made into rods using electrical beam melting, extrusion, machining, or other processes. The second step is zone melting, which is mainly affected by the raw materials, vacuum pressure, and the zone melting times. To do this, you put the zirconium rod vertically inside of a vacuum chamber, then using the electron gun as a heating source to slowly melt one side of the rod, moving to the other side. The third and final step is checking the rod for product quality. It is inspected by two main measurements: the mass spectrometry and hardness determination. E-beam melting and purification. In this method, the zirconium is bombarded with electrons in a vacuum seal to melt it. The gas dissolved and the zirconium can escape, and the mixed oxide can be evaporated or decomposed. This process, which includes electrical properties, magnetic properties, and mechanical properties of the zirconium, gets purified by the electrical beam. The larger the scale of the vacuum seal is, the lower the smelting cost of the zirconium becomes. However, the quality of the purified metal is determined by the raw material, melting speed, and power of the furnace. How to fabricate zirconium. The fabrication of zirconium involves many steps in order to create the desired material for many different applications. Preparation of raw materials. Zirconium is mainly extracted from zircon sand. This sand is heated with carbon and steam of chlorine gas to then convert it into a crude zirconium tetrachloride. Kroll process. This process involves chemically converting zirconium tetrachloride into a chloride, then reducing the product with magnesium, then resulting into a zirconium sponge, which is a further purified into usable metal ingots. Sintering the metal. The raw material is prepared, pressed, then sintered to form a dense solid. This process removes any void between the particles and combines them. Processing. The processing can be done in many different ways, such as powder processing, collegial processing, and additive manufacturing. These different processes are used to enhance both the physical and chemical properties for the specific application the metal is being used for. Injection molding. The necessary tools are gathered to make the mold needed for design. The mold is then placed into a furnace to turn into a dense product. Finishing of zirconium. The finishing of zirconium includes polishing of the material in many different techniques. This is to ensure the product has smooth surfaces as well as enhancing the material's properties. One technique involves using hybrid fine diamond particles. These particles ensure the product has smooth cuts while also minimizing heat the metal generates. Another technique involves a vacuum air furnace, in which the zirconium is melted in a furnace to form a solid metal ingot while also removing any impurities. These techniques are mandatory to make sure the metal can achieve high purity and durability. These achievements are crucial for various applications, such as nuclear and chemical needs. The image on the right is an image of a vacuum air furnace used in one of the finishing techniques. They can vary in size and heat to get the finished product faster and achieving higher purity. Examples of finished products. Nuclear grade zirconium. This product of zirconium is mainly used as a structural material for nuclear-powered aircraft carriers, nuclear submarines, and civil nuclear reactors. With its distinct properties, it's able to work well with uranium and is an important material for strategic metal. Zirconium silicate. This product is made from zircon sand, being mainly used for color glazes for architectural ceramics, daily use ceramics, and electrical porcelain. However, it's also used in other industries such as high-grade refractory materials, precision casting, and emulsified glass. Industrial grade zirconium, mainly used by the military for chemical and alkali resistant equipment needed, but is also used in the civil industry for electronics, pipeline valve materials, electric vacuum, and high temperature allied materials. Fused zirconia. Many times it's not often used because of its high content of impurities, but it can still be used in the production of glazes and refractory materials. This is my reference. I mainly use Zirconium World for two of the references. Then I use Britannica, nuclear power, and then Made How.